What's up, guys? In this video, I'm gonna go through with you this LeetCode 17 letter combinations of phone number. So, given a string, digit from 2 to 9, 8 inclusive, return all the possible letter combination that the number would present. So, return the answer in any order. The mapping of digits is given below, and note that 1 and 0 is not mapped to anything. So let's see for this example, 2 and 3. So 2 and 3, as you can see, 2 can be mapped to A, B, and C, and 3 can be mapped to D, E, F. So we pick one character at a time. So when we pick A, and then we have three choices, either D and E, F. So A, D, A, E, and A, F. A, D, A, E, and A, F right here. And then we move to the next one, which is B. And then we have three choices again. So B, D, B, E, and B, F. So it's just exactly that. And then we do the same thing for the last character for for this A, B, C, for the number 2. And then we have that as well. So, and then this is a trivial case. And also, if we have only one number, and that is going to return all the character associated with that number. So this question was asked by Amazon, Microsoft, and all other big names. Let's go through the solution together, and we will use a recursion method to solve this problem. First, we build a dictionary that we mapping the numbers as in character to those characters. So yeah, this is exactly that. For example, 9 maps to x, w, x, y, z. So this is exactly that. And we have a recursion function, and that takes in. I don't think we need this guy. So we have a recursion function which will be called recursively, and this is before anything we need a termination condition where if the pointer points to the length of the digit. So basically, if we're talking about index, the last index will be the length of the digits minus 1. However, when we point to the one after the last digit, that means we point to nothing. That means we finish the whole thing, and then we can append the combination that we are accumulating when we recursively calling this function, and also we terminate it by using the return. And then we look for the characters by using this mapping and digit and then call on the pointer. So for example, the first pointer will be index 0. So index at the 0 index, no, sorry, the digit at the 0 index, and that will be the key, and then look up the characters. That will be a temp. For example, when we are given a digit of a 2, 3, the first pointer will be 0. So this guy will be 2, because this one will be 0, and this one will be 2. And you have to look up dictionary. So the temp will be A, B, C. So for all the character in A, B, C, we will recursively call this guy. So the pointer will be moved to the next one. So we add 1 to the pointer, and also we will be concatenate the current character to the combination, and then this one will be the input argument for the recursive function, which you will be calling again. So we basically keep adding. Basically, we keep adding character by recursively calling this function until a point where we reach this boundary condition, where we will append the combination to the answer, And this is where we can trigger the whole thing running. This is a starting point. We're starting at index 0, and we're starting with an empty string, and then we keep adding to it, and then until the point where we reach to the last index. I mean the last index plus 1. This is the termination condition. So let's submit that, and it works. And let's look at the complexity analysis. It's slightly, the official solution is slightly different than what I'm presenting, but the complexity analysis is the same. So what it's saying is the time complexity is 4 to the power of n. So the reason why it's 4 because that's the maximum number of characters. So it's looking at, I mean, most of the number has 3 characters, A, B, C, and D, E, F, but 7 and 9 has 4 characters. So the worst case scenario will be the digit will be all 7 or 9. In that case, for each of the character, the next one we have 4 options. For example, we choose 7 and 9. So 7 we have 4 options, and then 9 have another 4 options. So in total, for the case 7 and 9, in total you will have so you will have 4 to the power 2 will be 16. So and then if you add to it like 7, 9, 7, and in that case each one you have 4 options, and now you can choose 3 times, so it will be 4 to the power 3. So this looking at the worst case scenario, and the n comes from the time when we need to, I mean the time for which we need to build a combination. For example, each time when we add to the combination, and that takes a little bit of time, and for a digit of length of n, so in total will be big N of time, because we added 1 each time, and then we add n times. Yeah, so that's the time complexity, and for space complexity is big O of n. So, and that mostly comes from the stack of which storing the recursion function. So allow me to read this for you. So not counting the space used for the output. So that's talking about this answer. And the extra space we use a relative to input size if space occupied the recursion call stack. It will only go as deep as the number of digits in the input, because whenever we reach the depth, which we reach here, this whole thing will be terminated. So basically we recursively calling the function until when this termination condition is reached. So we will call this guy n times. That's why the space complexity will be O n. However, I a bit reserved on this answer, because the solution, I think is big O of n plus 4 to the power of n, because that's the number of combinations, right? So I think this is underestimating the total space complexity. I think it should be 4 to the power of n, because that is this answer array takes the space. That's the total number of substring, if I explain correctly. So that's so much for this solution, and I hope you like it. If you do, please hit the like button and subscribe to the channel. That will support my channel a lot, and hopefully I will see you in the next video. Thank you. Bye bye.